Okay, so in previous lecture, we were discuss about asymptotic notations. What is the fundamental of asymptotic notations and what is the cases of asymptotic notations, and we also discussed about big O notation. After that, in this way, we will discuss today about omega notation or theta notation. And we will first start with omega notation. That will be represent the lower bound. We can say a tight lower bound. Okay. So you can see in this
Sir?
particular graph. Yes.
सर जो इसमें लोअर बाउंड जो बोलते हैं वो क्या होता है, मतलब सी इंटू जो
Lower
जीएफ है?
bound. Lower bound means we can say algorithm taken time minimum. उससे कम टाइम में पॉसिबल नहीं है उसका सॉल्यूशन,
ओके सर.
है ना. Here the lower bound is this, that is the lower bound, or that is the our main estimation function f of n. So f of n की वैल्यू जो है वो या तो इसके बराबर यहाँ हो सकती है या फिर उससे ज्यादा हो सकती है, इससे कम कभी भी नहीं हो सकती. It will be the lower bound, or we can say tighter lower bound. ओके. ये हमें बेस्ट केस को रिप्रेजेंट करता है, यानी किसी भी प्रॉब्लम को सोल्व करने के लिए जो एल्गोरिथम्स भी हम यूज करते हैं, देन विच इज परफॉर्म बेस्ट और विच इज टेकन मिनिमम टाइम, दैट इज द लोअर बाउंड, और उसको हम ओमेगा से रिप्रेजेंट करते हैं. एफ ऑफ एन मेनली आपका फंक्शन है जो कि आपकी टाइम कॉम्प्लेक्सिटी को रिप्रेजेंट करता है. ये एफ ऑफ एन मैक्सिमम हो सकता है, यानी इससे ग्रेटर हो सकता है, बट इससे लेस नहीं हो सकता. दैट इज ओनली इक्वल और ग्रेटर. वी कैन सी इन द इक्वेशन ऑल्सो, देयर विल बी in equation representation we can see the value of f of n is always greater than or equal to c multiply g of n. It is always happen in case of omega notation, or we can say in best case time complexity. Okay, n is always greater than equal to n0. So these are two things we have to notice in this particular equation. Okay. So f of n is always greater than or equal to 0, but f of n is always greater than or equal to c multiply g of n also. ठीक है. It means अगर कभी बाई चांस f of n की वैल्यू 0 हुई तो c multiply by g of n must be 0, वो भी 0 ही होगा. Okay. So it will be the equation and
सर
yes.
अभी आपने जैसे बोला एफ ऑफ एन जीरो होगा तो सी इंटू जी ऑफ एन जीरो हो सकता है, क्या वो निगेटिव नहीं हो सकता है?
निगेटिव तो नहीं होगा बिकॉज ऑफ देखो किसी भी प्रॉब्लम को सोल्व करने के लिए कभी भी माइनस में टाइम नहीं जाएगा, है ना. देयर विल बी नो वे टू गो इन नेगेटिव.
यस सर, यस.
है ना. दैट्स व्हाई वी डोंट इंक्लूड नेगेटिव entities. Okay, so we will discuss it. That is the equation for this particular notation, f of n equal to omega g of n, है ना. और मेनली बिग ओ के अंदर यहाँ पे क्या था, ओ नोटेशन था. दैट विल बी द सेम इन ऑल थीटा एंड ओमेगा एंड बिग ओ, है ना, ये कॉन्सेप्ट आपका सेम ही रहेगा सब जगह में. Only the change is that somewhere we found lower bound, somewhere we found upper bound, and somewhere we found at equality, or we can say average case. Okay. So there will be some basic points included about the omega notations, like it is work on tight lower bound because of it finds always the best case of that particular algorithm. So what is the time consumed in best case, or we can say, so it represents the best case time complexity for the algorithm. It means the lowest amount of time. Okay, so these are the circumstances for that particular omega notations, and now we will discuss about some examples about the omega notations. So that will be the unique equation for the omega notation that we already discussed in previous slide. So it will be the first example of the omega notation. There will be the time complexity for the equation calculated in form of 3n plus 2. That will be the time complexity. And the method will be same. If we talk about the solution first, then the equation is f of n equal to omega g of n. And then at the place of g of n, we assume n. Okay. And after that we will find the value of c, but there the condition is just reverse from the we can say the notation of big O. बिग ओ में हमने क्या किया था, वहां पे हम अपर बाउंड फाइंड कर रहे थे. अपर बाउंड में हमने क्या देखा था कि या तो हम 3 लेंगे या 3 से बड़ी वैल्यू लेंगे, ग्रेटर देन. बट हियर द सिनेरियो इज चेंज्ड. यहाँ पे हम या तो 3 ले सकते हैं या 3 से छोटी ले सकते हैं, लेस देन 3, नॉट ग्रेटर देन 3 or less than 3 we have to prefer, because of we go with the lower bound. हम lower bound के साथ यहाँ. Okay, then first we will take the value of c is 3 and put the value in the equation, and then we find the value of n to satisfy this particular equation. And what is the value of n for satisfy this particular equation? That will be we can say equal to 0. If we put the 0, then that will be 0 and it will be 2. So 2 is greater than equal to 0, है ना. और ये चीज हम जब अपर बाउंड में जब सेम वैल्यू रख रहे थे तब भी ये आ रहा था, वहां पे लेस देन आता है बस, है ना, लेस देन इक्वल टू आता है. सो वहां पे भी वो चीजें वर्क करती है जो यहाँ पे वर्क कर रही है. So we can say here it will be equal to 0, and then in second case we will take the value of c is 2. Then what is the value of n? We can say the value of n is here also we will put the 0, so that it makes 0 and it makes 0 and only 2 is here, so the 2 is always greater than 0. We can take the value 1 and 2 also for the n, and we can check if the condition is satisfied, then we can take n0 that particular value also.
सर बिग ओ में भी तो n नॉट ग्रेटर एंड इक्वल टू तो आ रहा था सर, ओमेगा में भी वही आ रहा है.
बिल्कुल. देखो ये मैंने आपको स्टार्टिंग में बताया था कि देयर विल बी सम वैल्यू लाइक 2.000. यहाँ कोई आवर्स का डिफरेंस नहीं रहेगा वर्स्ट केस, बेस्ट केस और एवरेज केस में, ये नहीं है कि कोई सेकंड्स का या मिनट्स का या आवर्स का डिफरेंस आएगा. देयर विल बी माइनर डिफरेंस लाइक माइक्रो सेकेंड, मिली सेकेंड्स, दीज काइंड ऑफ थिंग्स. So these all values are treated as we can say 2, but here one is the best case, one is the average case, and one is the worst case. In all three, there is no major difference between all three values. Almost these are 2, but it will be the best case. It means the lower bound. And it will be the average case. It means equality. We can say theta, that will be discussed in next section. And it will be the upper bound. तो ओनली इतना ही डिफरेंस रहता है. तो यहाँ पे जो आपकी कॉम्प्लेक्सिटी आएगी वो तो एन ही आनी है, चाहे आप लोअर बाउंड में रिप्रेजेंट कर लो, चाहे आप अपर बाउंड में रिप्रेजेंट कर लो. दैट विल बी एन, not other than n. Because of we need to represent with n, that's why we can say if we increase the value of n in drastically, then it will, if we decide a minor differences here, then we can't calculate for these all particular values. That's why we represent it in फॉर्म ऑफ n. यहाँ पे हम जो कांस्टेंट वैल्यूज हैं उन पे ज्यादा फोकस नहीं करते हैं, क्योंकि दैट विल बी एल्गोरिथम विल बी अप्लाइड ऑन 2 वैल्यूज आल्सो, और इट विल बी अप्लाइड ऑन 2000 वैल्यू आल्सो. तो अगर यहाँ पे हम पॉइंट्स में जो वैल्यूज है या जो टाइम है, अगर उसको हम साथ में लेकर चलते हैं तो फिर कैलकुलेशन विल बी वेरी कॉम्प्लेक्स. सो ये तो आपका सेम आएगा, ओनली रिप्रेजेंटेशन जो है ना वो डिफरेंट है. एन विल बी सेम. आप इसको एवरेज केस में भी देखोगे तो एन ही आएगा. लीनियर सर्च की टाइम कॉम्प्लेक्सिटी, चाहे आप बेस्ट केस में रिप्रेजेंट करो, चाहे आप वर्स्ट केस में करो, चाहे आप एवरेज केस में करो, दैट विल बी ऑर्डर ऑफ एन और ओमेगा ऑफ एन और थीटा ऑफ एन, because of it is totally dependent on value of n. So only जो आप मेनली ये ग्राफ जो बता रहे हैं ना, आप इससे बस एक आइडिया लगा सकते हो कि हम इसको किस प्रकार से ट्रीट करते हैं. बट इन मोस्ट ऑफ केसेस क्या, हम सभी केसेस में यहाँ पे 0 ही वैल्यू लेते हैं, क्योंकि लोअर बाउंड में इससे छोटी वैल्यू कुछ हो नहीं सकती हमारे पास. दैट्स व्हाई वी ऑलवेज गो विद द 0 वैल्यू, because of we have to get in right side smallest value, और राइट साइड में स्मॉलेस्ट वैल्यू करने के लिए हमारे पास 0 से अच्छा कोई ऑप्शन होता नहीं. दैट्स व्हाई वी ऑलवेज गो विद द 0 इन ऑल केसेस ऑफ ओमेगा नोटेशंस, और वी कैन से बेस्ट केस नोटेशंस.
सर बिग ओ में सर उल्टा कर देंगे वहां पे जो.
बिल्कुल 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 राइट. So there will be the another example 27n square. ये सेम हमने बिग ओ के अंदर लिया था और सेम आपने यहाँ पे इसको लिया. तो the value of g of n assumed in form of n square, and then value of c is assumed as 27, because of here value is the 27. So we can take 27 or less than 27. Okay, so in both cases here will be 27 and here will be 20. So after that the value of n, here also we will take 0 and here also we will take 0, है ना. ये हमेशा हम 0 ही लेते हैं, लोअर बाउंड में हम 0 ही लेते हैं, क्योंकि देखो सबसे पहले टेबल मैंने आपको बताइए, आपको 0 से पुट करना स्टार्ट करना, तो जब 0 पे सेटिस्फाई हो रही है तो वाई वी go with another values.
Yes, sir. Yes, sir.
है ना? That's why we always go with the 0, or we will easily satisfy this equation with the 0.
Okay, sir.
Okay, so I will skip these all omega notation examples, and we will uh, take first the theta notation. है ना? Okay, now we will discuss about the theta notation, that is also known as sandwich bound. It means there will be performed average case that will be always between big omega notation or big O notation, or we can say that is vary between the lower bound and upper bound, tighter lower bound and upper bound. We can understand this using that particular things. We can say if we think about that it is that tighter upper bound, and it is that we can say tighter lower bound. So between them, if we vary anywhere, we can say it will be 2.0, or we can say it will be 1.90, we can say it will be 2.10. These are all in between of both. Okay, these are represented using we can say theta notation. बट मैं आपको ये भी बता दूं कि मोस्ट ऑफ केसेस में हम जब टाइम कॉम्प्लेक्सिटी की बात करते हैं तो हम ऑलवेज बिग ओ नोटेशन से ही रिप्रेजेंट करते हैं. वी ऑलवेज गो विद अपर बाउंड. स्पेशली अगर पूछ लिया जाता है कि आप लोअर बाउंड में रिप्रेजेंट करो या एवरेज केस में रिप्रेजेंट करो, देन वी विल गो विद द theta notation or omega notation, but otherwise in 95% of cases we will represent the time complexity using the big O notation in our syllabus. Okay, so the equation of this particular notation will be like here will be we can say two functions are included, like big O notation and big omega notation, and for all n the value of n is greater than n0. Okay, I think it will be the because of this. Okay, that is n naught, and we will found these all things after that boundary, not before that. We don't calculate about this area. That's why the value of n naught is 0 or greater than 0. We can understand this scenario by using this particular graph, or we can say all these three graphs of big O, omega and theta notations. We will start the calculate of these complexities after the n naught, not before the n naught. So we can't take the value of n naught less than 0. हम लेस देन 0 वैल्यू n नोट की ले ही नहीं सकते, चाहे वो किसी भी टाइप का नोटेशन हो.
यस सर।
है ना, थोड़ा सा इसको विजुअलाइज करो कि जब हम एन नोट से पहले कैलकुलेशन परफॉर्म कर ही नहीं रहे हैं, देन व्हाई वी गेट द वैल्यू ऑफ एन नोट लेस देन 0, है ना। तो उसकी कम से कम वैल्यू एन नोट की 0 हो सकती है, अदरवाइज वी गो विद द greater than n0. That's why in omega notation, we always take the value 0. That is the lower bound. Lower bound. We can say कि एल्गोरिथम यहाँ से स्टार्ट हुई और यहीं फिनिश हो गई, है ना। यानी इसको जस्ट स्टार्ट होते ही फिनिश हो गई, इसका मतलब जस्ट वी हैव टू टेक एग्जांपल लाइक लीनियर सर्चिंग। हमने एरे में सर्च करना स्टार्ट किया और फर्स्ट 0 नंबर इंडेक्स पे हमें वैल्यू मिल गई, है ना। तो दैट विल बी द बेस्ट केस, बट एन नोट की वैल्यू 0 से कम तो नहीं हो सकती यहाँ भी, है ना।
यस
दैट विल बी द सिनेरियो। तो दैट इज यू हैव आल्सो करेक्ट इन ओमेगा नोटेशन इज आल्सो। ओमेगा नोटेशंस में हमने जो ये वाली कंडीशन देखी थी ना कैलकुलेशन पार्ट में, दैट विल बी द राइट। आई थिंक इन इक्वेशन आई विल पुट द सिंबल इज रॉन्ग। ओके, सो कैलकुलेशन में जो कंडीशन थी एन की वैल्यू जो है वो एन नोट से इक्वल या ग्रेटर ही होगी, इट विल बी द राइट।
ओके।
उस टाइम एक्चुअली वो ग्राफ को हमने ढंग से जब आपने क्वेरी की थी तो ग्राफ एक्चुअली सामने था नहीं, तो दैट्स व्हाई द कंफ्यूजन इज क्रिएटेड। ओके, नो इश्यू, वी क्लियर on the n node value, and the mathematically it will be represented about using this algorithm. It is always the greater than, it is the value of function, not the value of n, ध्यान रखना। इक्वेशन में जो हम रिप्रेजेंट कर रहे हैं दैट इज द वैल्यू ऑफ these functions. Okay, so the value of C1 multiply G of n is always greater than equal to 0 and less than equal to f of n, and the value of C2 multiply G of n is always greater than equal to f of n. यानी f of n जो है वो ऑलवेज बिटवीन वेरी करेगा किसके किसके, C1 और C2 के। G of n is the common factor, but cost 1 and cost 2, these are two cost, and f of n in case of theta notation always between cost C1 और cost C2, है ना। इसकी हमेशा ऑलवेज जो कॉम्प्लेक्सिटी होगी वो कॉस्ट C1 और C2 के बीच में होगी। दैट विल बी एनीथिंग, वी कैन से these are the cases, it will be the anything from these cases, it will be 2.0, it will be 1.90, it will be we can say 2.10, है ना, because of both these are in between lower bound and upper bound. So it will be the C1 cos C1 according to this graph, because of the lower bound is represented here by the C1, and that will be the C2, that will be the upper bound, and it the theta notation is always vary between both. I think it is clear to all of you.
यस सर।
Okay.
Yes, sir.
Okay, then it will be the notation f of n equal to theta g of n. And these are all common for all notations. Only the symbol is changed. So the theta notation here, tight bound, we try to find only on equal, or we can say it will be on average case, or we can say average amount of time. It will be the equation for same. It already discussed on previous slide. So it is the first example. The same example taken here, 3n plus 2. So according to equation, here will be C2 and C1 and C2, two complexities are calculated here. It will be a little bit complex as compared big O notation or omega notation, because of the equation is little bit lengthy. So at the place of g of n, at both side, we will take n. Okay, it is clear. It is according to previously discussed methods, and then we will find the value of C1 and C2. Okay, so first we will try to according to big O notation. Okay, so according to big O notation, the equation is 3n plus 2, and it is greater than equal to 4n. यानी कि ये वाला पार्ट जो है वो हम ले रहे हैं according to big O notation. Why the 4n? Because of it is satisfy on value of C4 and value of n is 2. है ना, यहाँ पे मैंने पूरा डिस्क्राइब नहीं किया क्योंकि बिग O नोटेशन हम कैलकुलेट करना ऑलरेडी सीख चुके हैं. That's why I directly put the equation of big O notation. Okay, that is clear. You can calculate it. You can put the value of C, and then according to you can find the value of n naught. So it will be the satisfy. You can try that. 4n, it means we can, the value of n is 2. So there will be 8, and here 3 multiplied by 2, that will be 6, and plus 2, that will be 8. So it will be the satisfy. And next one is the equation according to omega notation. So that will be, we can say it is the part of, you can take anyone in the any part. Okay, so यहाँ पे ये greater than को represent कर रहा है, ठीक है, तो ये omega notation में आपका आ जाएगा. यहाँ पे ये less than को represent कर रहा है, it means that will be the big O notation. ये आपका greater than को represent कर रहा है, it means it is the part of omega notation. So there will be the value of C is 3 and value of n naught is always 0 in the omega notation. Okay, so these both the cost of both C1 and C2 are calculated. We can say it will be the cost of C2 and it will be the cost of C1. So the lower bound cost is 3 and upper bound cost is 4. That's why the theta notation represent in between 3 to 4. ये आपका कहीं 3 और 4 के बीच में कहीं भी आ सकता है. That will be 3.1 or that will be 3.9. Okay.
Yes, sir.
No. So it will be the graph representation, some kind of things like linear or exponential, है ना. हमने स्टार्टिंग में बात की थी ना, order of n and order of n square. So the graph is represented as it is the order of n and it is the order of n square. Okay. Some general rules for the estimations
सर एक बार
here.
प्रीवियस स्लाइड करना.
Yes. You have any query on that particular graph?
हाँ सर ये
It is just representation of order of n and order of n square. It means we can say the whenever it is represent the value of n, it is the represent of value of n, and it is represent the we can say the order of n. It is represent the order of, it means the time complexity. So the value of n increased when value is 1, when value of n is 2, value of n is 3 and 4 and 5. So if the complexity is linear, then it is not increased drastically. It is just we can say the parallel to the n. जितने नंबर ऑफ एलिमेंट्स होंगे उतने कंपैरिजंस और उतनी प्रोसेसिंग वहां पे बढ़ती जाएगी. But there will be if any kind of loop we have to use, then there will be the complexities in loop is we can say n square because of the statements repeated in exponentially. That's why the complexity is increased exponentially.
ओके सर.
So some general rules are included here for estimation. First of all, we will discuss about the loop and then nested loops, then consecutive statements and if else. So we have to read all these statements carefully. First, we will read the statement given about the loop. So what will be the loop will be the do. Loop का mainly क्या काम होता है? Loop is used to we can say repeat something, or we can say that it is the iterative statement. Okay. Running time of loop is at most the running time of the statements inside the loop, or it is totally dependent on the number of iterations. Suppose there is a loop, I can say there is a while loop, okay, and there will be the condition is 1 is less than equal to n. And some statements are here. Then what is the complexity of that particular loop? Obviously that is we can say n times. N steps are performed here, or we can say n plus 1, not only n, because of condition also once check on the wrong also. So that will be executed at the time of n plus 1. But we can't include the constant values in our estimation. That's why the complexity of that particular statement is order of n. If we get a loop inside the loop, here we can say another while loop, then what is the complexity of that particular inner loop? That will be the n square. We already we can say learn about them in time complexity. नेस्टेड लूप्स का हमने देखा था कि उसका जो स्टेप्स है वो n मल्टीप्लाई बाय n+1 आ रहा है. Okay, so these things are mainly mentioned for loops. And if we talk about nested loops, we already discussed about nested loop. And then the conservative statements, like we can say the statements like single statements, or we can say some kind of statements like jump statements, and what is the processing of these statements. And for these all statements, we will calculate the uh, complexity, or we can say the steps of execution according to uh, these execution steps. If else, we have to calculate according to condition, and we have to calculate according to statements. There in if else, we need to focus on that the statement of if or else. There will be execution of statements either only the condition of ifs or the condition of else. या तो if का ब्लॉक जब एग्जीक्यूट होगा या else का होगा. So ये चीज इसके अंदर मेनली फोकस करने वाली, ध्यान देने वाली.
सर ये थर्ड वाला एक बार फिर से बता दीजिए ना, उसमें क्या
conservative these are the statements like value assignment, like the function calls, like the jump statement, like we can say the break, continue, and go to. These are the statements, and these statements don't have any unique we can say calculations. So we have to calculate according to this performance or according to these steps. Okay.
Yes, sir.
Algorithm growth rate. If we talk about algorithm growth rate, then we can say these are also the representation of notations like where is the my pen? Okay, n square, n cube, or we can say it will be also in something power n. It will be also included in exponential. These are all in exponential, and we can say sometimes we find that these exponential are also multiply sometimes, like double of n square. Okay, and we can say triple of n square. अब यहाँ पे हम n क्यूब नहीं कर सकते. n क्यूब करेंगे तो बहुत ज्यादा इंक्रीज हो जाएगा. But we can just make them double, triple, or we can say fourth, or we can say multiply by fifth. These are some factors we will include with these we can say unique notations. These are some unique notations we already discussed in very starting slides, like order of n square, and log n. These are three unique identifications: linear, exponential, and logarithms. So in linear or in logarithms, or we can say in exponential, there will be some more things we have to add, or we can say we can manipulate according to requirements. नहीं, स्टार्टिंग में आप लोगों ने क्वेरी भी की थी कि सर इसके अलावा भी कुछ नोटेशंस हो सकते हैं, तो दीज आर द issues we can represent using these unique notations. Okay, so algorithms time requirements we can measure using different functions, or we can say we can measure them according to the size of the problem. We have some uh, notations, but we need sometimes some more manipulations, or we can say identifications add to them. Like the here one example, the taken problem size depends on the application. How it is depend on the application. Here is the example: number of element in list for a sorting algorithm. है ना? There will be the you have to calculate the